Kia ora, Year 12 and 13. This is question 3, the first half of it from last year's 2016 differentiation paper. So this is an achieved question and then 2 merit questions. Make sure that you try and do the questions before I go through them. Okay, so this one is a very straightforward differentiation problem. It's just the chain rule. So let's pop it into exponent form. So f of x is equal to 3x plus 2 to the power of 1/4. So f dash of x will be 1/4 times the inside function to the power of negative 3/4 times the derivative of the inner function, which is just 3. Okay, it's fine to leave it like that. I'm going to clean it up just to make sure you've got some practice for surds. Always comes in handy, especially in complex numbers. So that's going to be 3/4 of this. There we go. Okay, on to the next question. Okay, on to the next one. Find the x value at which our tangent to this curve is parallel to the x-axis. Well, sounds hard, but it's really easy. Parallel to the x-axis means that the gradient is equal to 0. So all I have to do is take this function and differentiate it to find the gradient, and then solve for where the gradient equals 0. So the gradient of this will be 6 minus, chain rule again, minus 3e to the 3x. And we want that equals 0. So we get 6 equals 3e to the 3x. 1/2 equals, no, not 1/2, what am I doing? 2. 2, not 1/2. Just get rid of that. Fix that up. So 2 equals e to the 3x. Take the natural log of both sides. So we get log of 2 equals 3x. So x is equal to 1/3 times the log of 2, which is 0.231, and that's just to 3 decimal places. Okay, I've got a rectangle here that I've got to work with, and the rectangle's formed by this curve here. Right? It's got one vertex here at the origin, and the other vertex is on the curve. So what we're trying to do is figure out how can that rectangle be as big as possible. But we know that this here is going to be x, so the width will be x. What will the length be? Well, if it's on the curve, this value must be x minus 6 squared. So that means that the area of the rectangle will be length times width, so x times x minus 6 squared. On the next slide, I'm going to figure out how can we find that that's a maximum. Well, we're going to find the first derivative and set it equal to 0 and solve. Okay, so we've got a of x is equal to width times length. Now we might as well expand that out. It's going to be x times x squared minus 12x plus 36. So that's x cubed minus 12x squared plus 36x. The first derivative is equal to 3x squared minus 24x plus 36, and that has to equal 0 for a maximum. So what am I solving? Well, we need 3x squared minus 24x plus 36 equals 0. Dividing through by 3, I get x squared minus 8x plus 12 equals 0. So x squared minus 8x plus 12 equals 0, and that's going to give me 2 solutions. It's very easy to factorise. X minus 6, x minus 2. Now just think back to what we've got here. Oh, bad graph there. So that's 6 there. So we know that x equals 6 is going to give me an area of the rectangle of 0, because the height here will be 0. So it's going to be my minimum. And then at x equals 2, this is going to be my maximum. But I'm not asked just for the x value, I'm asked for the area of the rectangle. So y is equal to x minus 6 squared. So at x equals 2, that will be 16. And so the area, when x is 2, will be 2 for the width times 16 for the height, which is 32 units squared. Okay, but because there weren't units, it's fine just to give your answer as 32. Alright, so that was a merit question. I'm going to do the 2 excellence questions shortly. Thanks for watching.